Recording. Recording. I am expecting some questions from you. None of you done the past year question. May 2023A. May 2020. Then I check May 2020. May 2020. May 2020. May 2020. My file is a bit messy. Not sure. Is it this one? 1 minute. September 2020. May 2020. This one is it? Corbin go for lunch. Go lor. Yes. Delta Y or Y delta. But in your syllabus, normally I ask yes. Normally, the question will be YY. If YY, that means you draw exactly as the diagram only. Okay, this is a tips. Okay. Anything okay? Most question be YY. Then 2A. Nicholas asked for 2A. 2A. 2A? Explain 4 design criteria in Nicholas, this one. Yeah, from the notes of the design criteria in protection system, the economy considerations, those economy factor. I can't remember. Electrical factor, right? Environmental factor. So the design criteria. Reliability, selectivity, speed, economic, simplicity. This one. Design criteria. Protection protection system, right? It means the second last chapter system protection. Chapter 8. Okay. Done. This one. Economic research should be okay, right? Then we look at question 3. Can you try to read question 3? Yes, yes. Positive and negative sequence are in this chapter. Okay, look at it. So we have three-phase fault occur at point F. I make it smaller a bit. The equipment ratings as usual, G1, G2, T1, T2. This one no need to use. Normally this kind of question no need to use percent. I give you PU, normally it won't be percent already. So you use as usual the PU questions. So draw the reactance diagram in per unit on a 200 MVA 15 kV base in the zone of generator G1 here, and determine the terminal equivalent of all the sequence level SU from the fault bus here. Then calculate the single line to ground fault. Assume all the three-phase fault are in systems are in YY connection. So YY connection means you draw exactly like this. Transformer, generator, transformer, line, parallel, then transformer 2, then G2, generator 2 impedance. Okay. This paper is what the plus minus we have? What do you mean by plus minus? This is May 2nd May 2020. What is G2? What is G? Is G2? Yes, yes, positive, only positive sequence has. Never mind, roughly the same. Okay, I think because of the different version, I can't remember which version I give to you already. Okay. Okay, we look at the way of doing that. It's roughly the same. Roughly the same questions, maybe edit a bit already. Okay. Then, how to do it? So first of all, what you need to do, first step, get PU. Not really. Then to get PU, what is the first step? Yes, set the base. Yes. So set the base first. So you need to know 15 kV start from the generator. Then the transmission line here will be 150 kV. And then after transformer 2 will be 15 kV. Then you find zero sequence. Then G1, T1, T2, G2. Okay. Is it okay? So because zero sequence and has its own value, right? But positive and negative sequence, their values are the same. So you can do zero sequence, then positive and negative sequence. Okay. So transmission line, you normally need to do for one time, since transmission line are the same for all the three sequences. Is it okay? So basically, something like this. E square over S, you find the base and then actual divided by the base, and you get the BU value for 912 and 934. Then that means the Tevenian equivalence. So you need to series here, parallel here, then series together, then series here, then parallel with both sides. Are you okay? So the diagram, I didn't draw a diagram. I can draw the diagram for you here. Maybe I draw here. So you have impedance for G1, then T1, then both the line 912, 934, then T2, and G2. Okay, we have ground here. So your fault is here. Okay, so basically this side and this side, both of the line parallel first, and you series. Then this side series and parallel. Left hand side and right hand side. Fault is here. This side and this side parallel. And you get what I mean? Is it okay? Then yeah, my thing answer only prep until TH4. Positive and negative sequence only. Oh yeah, positive sequence is just add generator, that's right. That's right. But then the answer for the ZTH is still the same, because you need to find you just write G1 and G2. So because you want to find the Tevenian impedance, right? So you use the Tevenian method, right? Then you need to short all the voltages. So you short all the voltages, actually basically it's the same as the negative sequence. Okay? So it's actually considered a very straightforward question. Okay? So I think okay? So you want to discuss this question, right? No, okay. What's your problem? Not this one. Then which one? Previous one? Which previous one? You mean this one? 2B. You want to know this 2B. 2B. This one. Add in. Different. That means perhaps is another question. Which question you mean? It's this one. Is it this one? Is it this one? This one? I think it's this question. Okay, 1 minute. If they didn't, yes, if no mention, that means Yeah, 1 degree, yes. 1 pu, not 1 degree. 1 degree, yeah, 1 degree. So okay. Then this one, what happened already? I had two questions of. I can't remember what happened. Seriously, I can't remember what happened. This one, this one also actually the answer is a bit weird. Suppose or suppose should continue another eh, yeah, I think this answer is for this. Okay, 1 minute before we go to this question, I would like to inform you about this. Okay, this one I haven't finished yet. After you find the Z0, Z1 and Z2, right? Then they ask for single line to ground fault. So you need to continue with the single line to ground fault diagram and get the current, yeah. Get the current. Is it okay? Yes, F confirm equals to 0. Just short the ZF value, location and just short the ZF there. And yeah, 1 pu for the VF is. Okay, then we go to Edine's questions. Edine's question is this one. So this is something like your exam that because I need to set 5 questions, so I separate out the two parts. Huh? Nicholas, your questions still haven't finished. Huh? What is the base? What is the base for the base current? Oh, you need to know where is it, man. If you are here, then what you should use? This area is this one we say 15K, right? Then from here to here is actually before you go out from the transfer is still 150K, right? Then here only 15K, so definitely you need to use 150K. Okay, so where to look? I mean, what is the voltage values? It depends on where is the location of the fault, since they say fault current, right? Okay. Yeah, no problem. Okay, then we go to this question. So yeah, your exam is something like this because I need to separate out into two parts. So one good thing is since it's not a continuous question, so I give you another new value for Z0, Z1, and Z2. Okay, then determine the single line to ground fault. So it's basically something like this. That you have 1 pu V voltage divided. Okay, so single line to ground fault, you draw out the circuit for single line to ground faults first. Then you find I0, I1, I2. Okay, then determine the voltage drop as usual. Circuit analysis questions are on the series circuits. Then convert back to VA, VB, VC. That's it. Edin, okay. Edin, why you have problem in this single line to ground fault? Okay, we only have conversion. What conversion? You need to convert anything, man. In PU. Okay, first you get the current first. After you get the current, then you can get the voltage. Then you can get the phase voltage. Okay. And in PU, I didn't ask for actual. So it's considered easy question. Sequence to phase. Convert from sequence to phase. Are you okay? It asks for sequence to phase. Actually, this one also in PU, but line to ground fault current and line to neutral voltages. Suppose the current also need to convert to. Suppose the current also need to convert to sequence. You okay? Eddie, okay? What do you want to ask? Where I get the matrix from? So you don't care about the matrix form. It's just you mean this one is it? Or this one? This one? You don't care about, hey, Edin, I want to know your head. This is not a matrix form. It's just that you write, you get what I mean? You know your last time you did. Okay? How you find we not plus minus we not is here, right? I think not. This one I think is plus here. I think should be plus here minus here. Plus here minus here we not. According to the diagram, diagram. Let me show you the diagram. You're not ready for final exam yet. Like that. 70. Single line to ground fault, right? Then single line there is a diagram. Okay, plus here minus here we not. Then you need to follow exactly this diagram. Then plus here minus here we not. So this is just a what? Series circle, right? Can you find V naught? So V naught is basically equals to a negative Ohm's law, I naught Z naught only. So you no need to care about this matrix form. Just that they want to write in the matrix format, then it looks neater only. Edin, can you get what I mean? Then what is your V1? V1 is minus here, plus here V1. Okay, so this point is actually VF. So yeah, your I1 is here. So that's why they say V1 minus VF. V1 minus VF equals to I1 Z1, right? Then your V1 equals to where's your V1? Or plus here. Plus here. Minus here. This point is VF. V1, sorry. So V1 equals to V1 itself should be equals to 1 VF minus I1. Wait, 1 minute. Let me double check where's your V1. Diagram 6. So V1 is here from this point to this point, plus minus here. So follow exactly the diagram. Huh? Okay, so your plus is not here, V1. Plus minus V1. Then V1 is basically V1 equals to what? Negative I1 Z1, right? Plus VF. So that's why you have VF minus uh, Z1 I1. Edit. Wow, what? Okay. What you wow? This is something that I did show you and learn before, right? And so basically this shows that the diagram is important. This diagram is important. Okay, you need to really follow exactly the diagram in your own three diagrams. So you have three types: single line to ground fault, then line to line fault, this diagram, and double line to ground fault. So it's not given in the exam, so you need to memorize the diagram. And good news is it will only come out from one of it. Okay, Edin, can you get it now? So this matrix format is not a big problem. This one you don't know how to write is okay, but you can write like this. Okay, just that they want to show neater, then they write in this form only. Edin, can you understand? Others? Huisan, can you understand? Renjian, Ziyuan, Yingxuan? Okay, make sure you understand this. If you can't understand, then yeah, I can go more details, very step by step. Can but let me know if you need it, the explanation of this. Why question just show, Just now got 3x, Which question? Why question just now show? Question 4. Let me go back to question 4. Question 4? Yes. What 3x? 3x? What do you mean by 3x? Because we have, I don't know what you mean. Question. This question. Oh, is it? Because we have zero sequence, positive sequence, negative sequence, This question is different. This question, they didn't tell you your Z0, Z1, and Z2. You don't know. You don't know what is this, what is this, what is this, you don't know. Then it's a very original question that you need to use from the diagram, find those PU things, and then find those PU things, okay, for zero sequence, for positive and negative sequence, for line. Okay, then you get the, then only you get the ZTH, ZTH, and then get the value for, then you get the value for Z0, Z1, and Z2. Okay, then only you can continue with the single line to ground fault whatever symmetric, unsymmetrical fault question. Okay, but this is different. This one I give you Z0, Z1, Z2 value already. I think can you get differentiate them? Is it what you want to ask? Is this a thing that you want to ask, Edin? Hello. How to know to use X? You need to use all. Edin, you need to use all X when finding zero. When finding zero sequence, then you use a zero sequence value for G1, T1, T2, G2. Okay, but line is the same for all. Okay. Then for positive and negative sequence, then you use a positive and negative sequence value for G1, T1, T2, and G2. You need to use all value. Okay, zero sequence when you find for zero sequence. positive and negative sequence, positive negative sequence, this one, x12, x12, positive and zero negative sequence, then you find for, understand, Adin? It's the same thing, you need to repeat doing for, supposedly it's for 3 times, just that now positive and negative sequence having the same value, so you only need to do 2 times. Yes, x0 is zero sequence, x1 is positive sequence, x2 will be negative sequence. And not only you know x0 is zero sequence, x1 is positive sequence, x2 is negative sequence. You talk in the sequence network chapter, right? Yes, it's confirmed already. Okay. Okay, you all, I think, haven't really do revisions, and now Scully clear up the. Hi. Where Scully clear out all the problems. Okay, good. Zero sequence confirm already. X0 for zero sequence, x1 for positive sequence, x2 for negative sequence. This is something fixed already. Okay. Huh? Must be same value for what? Depends on the questions, of course. Just that I I'm very good ma. I'm very kind, right? So that's why normally yeah, same thing ma. No need to do so many times. So normally positive and negative signal I give you same value. Normally it will be like this. X one two one two one two same. Then transmission line normally will be the same for all. Sometimes transformer same for all. Okay, so you depends on the questions lah. So you pandai look at this one means you only need to do 1 time lah. So you can write something like this, positive and negative sequence. Then you do only 1 time. Renjian, can you get what I mean? The terminal equivalent here is not okay. The terminal equivalent equals us what? The terminal equivalent. Why I can't see? 1 minute. So Edin asks first, if the question asks only negative sequence, then just consider x2. Yes, but unfortunately the question won't ask only for negative sequence. Normally we ask for all. Okay. The terminal equivalent circuit here is not the diagram you draw earlier, right? It's just a source and Z1 with an open port. Z1 with open port. Why Z1 need to open port? Which diagram? You mean this one, is it? Question 2B, is it? Yeah, if question 2B, then it will be something like this lah. Z0, then Z1, then Z2. Nicholas, is it what you want to ask? Oh, this is not an important diagram. Z0, Z1, Z2, Z1 is not an important diagram at all. This is an important diagram that you have to draw. Yes, but don't care about this Z0, Z1, Z2 diagram. This is an important. Single line to ground fault, line to line, and double line to ground fault is an important diagram. Okay, and unless I ask you to find this one, then you need to draw a diagram and find the Tevenian equivalent. That's it. Yes, only Z1 have VF. That's right. How to determine the fault contribution by The T2 only. What do you mean by T2 only? Transformer 2 or by transformer 2 only? Which question? Can you tell me the question? If this one is not by transformer 2 only, if this fault is by as I say, this side and this side, so parallel them. So series here, here series. Of course, this one line parallel. If question asks, no. The question will should definitely give you something like this: the fault location process or place. Question 4, the Venn equivalent. Yes. Question 4, definitely question 4. You need to do draw out the Venn equivalent. Then only you can find the location. The Venn, right? Oh, yeah. I know you are smart. Then you can straight away look at it. Then you will know where it's a parallel series. Of course, mark will be given for diagram. If you didn't want to draw the diagram, then deduct a few marks only lah. Not a big deal. No, the questions in this topic won't ask like this. Okay, I won't ask you determine from transformer 2 only. I will give you something like this. If that one, the question that asks contribute by transformer 2 is the question that you need to use the percent, this kind of percentage fault occur at the load end of the transmission line. Okay, yeah, double check the answer again. Which answer? My answer is not necessarily correct. So because I don't know, this is, I think it's the first draft version only. Did Edin, can you get what I mean? Then percentage symmetrical fault, the percentage questions is not in your final exam. Okay, that one already cover in tests. Edin, can you get what I mean? So these questions, PU questions, then I won't ask like that. So I definitely I will give you a fault location, the cross, then means from the cross place you find the variant. So means your eye need to look into the fault location, okay? Nicholas, okay? Done? Others? Yes, pattern like this, something like this. Okay. But I separate into two because how about I show you the question now? You ask until so detailed already. Okay. What is the difference? The difference is wait. The difference is I can ask you, for example, I think here 40 marks, right? 40 marks. Okay, I'll give you one question from the beginning until the end. You find the line to line fault current. Understand? So now, because that time, COVID time, I only set 1, 2, 3 questions. But then in physical test exam, I need to set 5 questions. So I separate into 2 questions here. So that's why this one, I think you find until the venue only. Full stop already. No line to line. The asymmetrical fault topic is not here. Then the asymmetrical fault, I will give you another questions that given this something like this, given this Z0, Z1, Z2 value, another question. Can you know what I mean, Edin? Do you know what I mean? Can you know the difference? Understand? So better, right? Now separate into 2 already. So other one is unsymmetric. Symmetrical, I consider. For me, it's just a Thermanian impedance diagram only, not really symmetrical question. So down a bit to where Z0 zero sequence I didn't find Z0 leh. See here. My answer is a bit incomplete. Values of the answer is not important. The most important thing is you know how to do. Okay. Any other questions? Huh? Huh? Wait, then R no need consider. R? What R? Say R here? Yes, you only need to use do with this method. You understand? You do this method, then you find the Tevenian, then this one, another question, then you find the symmetrical fault. Adding got R meh? Line R, need to consider. Line got R. Line got R meh? R? Oh, 8 ah. Yes, this is R. Then have to consider. I think I consider, right? 8 plus 10J ma. Consider. Adding, I consider 8 plus 10J, 5 plus 12J. So this is my R plus X. Adding, is it what you want to ask? Adding, you okay? Why today you seem a bit blur You already recover from COVID, right? Oh, yeah, fasting, Sorry, happy fasting. Oh, that means, Raya time, then you need to sit for the exam. Kasihan also. No, that one is a percentage question, symmetrical for percentage question. This one, the way of doing is a bit different. Okay? Because this one we straight away consider in complex number format already. In percentage question also have R, then they need to do they need to combine the what Z equals to square root R squared plus X squared. Okay, but here no need. You straight away complex power number settle them already. Yeah, it's actually the same. Yeah, we have some other issues in stone protest competition. Okay, any other question? Very clear? If you are clear, then I close this one. Oh, done, right? Close this one. Maybe we discuss these questions. This is this is September 2020. September 2020. Capacity load connected in parallel in order to improve the power factor. You should know how to do right? Then like your test. Okay. Then four cooling methods. This one is a theory questions. Then these questions is actually uh, yeah the mapping okay, secondary map to primary, then map to primary. Okay. Then we have these question, long questions. Then we have the explain the backup protection theory questions, and then we have this economic dispatch problem that I give limits. Okay, and let this. What's the year already? Uh, 2020 September. 2020 September. Are you still with me? 2020 September. This one. Password. I can't remember the password. Okay. I seriously I can't remember the password. Question. Skip. Is it this one? Why I feel like not the same? I think so. Wait, 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 not this one. Uh, yeah, minute 2020, so it should be this one. Question, yes. Yeah. And this one, we map to the primary side. There's one more transformer here, right? That map to the primary side. Okay, then these two combine in series of then map to the primary side again, then combine. But I think the answer got some problem. Okay, some calculation problem. I didn't update in the copy version. It's in the soft copy version. And then question two. Question two, like this. Then they say set the base to be 100 MVA, 80 kilowatt from the secondary side of transformer T1. So it should be from here. Okay, so it should be from here. So that's why you have 80K from here. 80K I start from here, then step down to 16K, step down to 16K. Then supposingly x12121212. This one easy. It means what? 1212, then 012 and inside for transformer and line they are the same. Or positive, negative, zero sequence are the same for T1, T2 and line. So you need to do G1 and G2 for different positive and negative G1, G1, G2, T1, T2. So zero sequence, G1, G2, transmission lines. So you draw all positive sequence, and negative and zero sequence, and for location here, then series here, parallel them, then you get the answer. Okay, so this is like your exam lah. Then you give a diagram, start from determine the new voltage value, then find the positive, negative transformer, zero sequence line. So okay. Then draw the impedance diagram. Then find from the four locations your I. Okay, look inside. Then short here. So this side series, then parallel them. Is it okay? Anyone need me to repeat how you get this? You know, right? X new X bu O V new O V O over V new power 2 and S new over S O. Okay? No need. Just leave it. Just leave it like this. Just like this. Okay. Oh, this one. Yeah, you don't want to link here. Okay, don't want to link also can. Not a big problem. No, it's not series because if fault location is here means your eye need to look inside here. So it's basically parallel. Yeah, I didn't. Yeah, so this is one question. Then these questions, of course, they continue with the I think with the line to line fault. Okay, with the line to line fault, then You continue with line to line fault, draw the diagram for line to line fault, and then determine the series circuits only. Then you determine the current or voltage that they want. Okay, I think this one is current. Then series circuits, then you put in the Z1, Z2 values that you got just now. Is it okay? So, but as I said, in your exam, this one is another question. So I give you a new Z1, Z2, Z0 value. Yes, you don't need to use Z0 because the diagram, yeah, I close because the diagram is follow exactly the diagram. Okay, it is a summary for the unsymmetrical fault already. Because this is a line to double line to ground. Okay, double line you have I0. Then this one now, there are zero sequence is another circuit. That open circuit like that only. So means V0, I0 equals 0. Okay, so you just follow this diagram. I V1, V2, I1. Is that clear? Yeah. It's easy, but if in the exam you forgot, oh yeah, this one is I1 or I2 or I0, then don't ask me. Because yeah, it's a very easy thing that yeah, you need to depends a bit of your memory. Okay? You seriously don't ask me because I also can't give you answer. My brain only can remember things for less than 1 minute. Okay? You should doubt me if I give you the answer. The answer may be wrong. How to get 16K? Where is the 16K? I think it's that out down. You mean this 16K, is it? Given is okay, there's a question. Given in the question is 80 kV, right? So your 80 kV is here. Then transformer T1 to transformer value is what? 20 so 100, right? So means times 5. So means your 80 need to divide by 5, then you get 16K. 人间, can you get what I mean? So this side to this side, they must follow the transformer ratio. So this one times 5, then 16 times 5, you get 80. Okay? Forgot already. That's why you only need to do revision. That's why I teach faster so that I can let you all do revision these few weeks. Face value not related at all. Usually it's the same. Face value not related. Basically it's the same. It's the same. Basically in the test, in the exam, it's not the same. Normally I won't give you 80 and here 80. Okay. Can read the questions properly in the exam. Okay. Any other thing that you like to discuss? Maybe we go to this one, theoretic. Maybe do this one. If there's a limit, then how are you going to do? So I believe we do as usual. Yeah, differentiate it, rearrange it, goes to lambda, then we rearrange it, then 3 equations, we settle, we get P1, P2, and lambda. So then we check the limit loss because in the question, right, P1 must be less than 800. So this one, P1 already more than 800. So P1 need to be lower than 800 megawatt. So P1 is fixed at maximum 800. So if P1 fixed at 800, then P2 will be equal to 1002. Okay, then substitute in the dC2, dP2, this equation to get lambda. Then you can find the cost C1 plus C2 equals to C total with the new P1, P2 value. So substitute into the question C1 and C2, then plus together to get C total. Is that clear? So your P2 is within range, 800 something is within the range. Your P2 is within range, but P1 more than the range, exceed the range, then we fix it at 800 maximum value. Then our P2 will adjust because the total need to be 2000. Hopefully this question come up. This question definitely in your exam. Yeah, something it may not be limit, but I think the limit is harder leh. I think the more straightforward. There are three cases, right? Losses, power loss, or limit questions, or the what is that? The normal questions lah. Okay, C1, C2, then determine the what value. Okay. So economic dispatch sure will have one question. Easy lah. This is really easy. A lot of students can score. 99.9% of students can score full marks for economic dispatch. My whole paper actually very easy. Just that I need to mark stricter. If not, then everybody get 100 marks only. Okay, so then I put in some theory questions so that can pull down a little bit of marks. Like that only. Basically, to pass is not a problem at all. Okay. Any question? If you don't have any question, then I will end the class now. Then I think I meet you again. Edin can pass. I think you can pass. Unless suddenly on that day you don't know what happened. May 2021. May 2021. All the notes should be in. Some from extra question. May 2021. Where is it? This is May 20. This one is. This is September 2020. I'm not sure. Is it? Is it this one? October 2021. Final count. May 2021. May 2021. Should be this one, I think. Yeah, is it this one? Which question? 1A. The most economical power factor. Yeah. It's actually, I can't remember. I think it's in extra notes also. Answer is given by Edin already. Good. Any other question? So okay. Also for D marks, then F location. Dim sum and power loss. Okay, so our next class will be the physical class. Okay, please let me know if you can't attend, yeah. One P? Which circuit? You mean this question, is it? This question, is it? What circuit? No circuit is given here. No circuit is given. Okay, I show you the answer. This one. Lot 1, lot 2, then lot 3, then combine all the S1 plus S2 plus S3. Okay, then after you combine, then you get the sun right angle right. Then you be your power factor. It's a bit messy. 2020. Oh, not this one. May 2020, not the one where we discussed. Eh, this one, eh? May 2020, is it the question that we discussed just now? May 2020, right? Where I put it already? May 2020, which one I opened just now? The, is it this one? Is it this one? This is actually not the final copy. I, which one? Is it here? Is it this one? Should be this one. Draw the equivalent circle for the practical transform. This question is basically the, the diagram in your lecture notes. Transformer is in chapter 3. Is it? Yeah. Where's the diagram? This one. Equivalent circle for practical transform. This diagram. It's okay? Yes, at least the same with all the labels. I think the question they ask is receipt exam and open book. So basically I give this purposely close eye to give marks only. You want to have this good service and you sit for receipt. Okay. Yeah, receipt questions easier a bit lah. Yes, open book some more that time. COVID time. I think it goes everything. Is it? Efficiency. This. Me. Me. 2020. May 20. May should be this question. Efficiency. You need to divide it by P, you need to divide it by the efficiency value. Yeah, if you have an efficiency question. Need to divide it by the efficiency. Not Q, P only. Efficiency only affect in your P only. Yes, not efficiency for PS and Q, only for P. Okay, because only for resistive load. Okay? If you divided by S then wrong because that means everything. Okay, so you just need to divide by the use a P divided by the efficiency value only. Then you get a new P, right? Then you use this new P value to continue with the question. And P only. If given S, you can get P and Q, right? It's not a problem, right? It's not a problem to get P, right? Is it okay? Yeah, use forward factor, then you can get P and Q. The rest of the answer. Top 3, P divided by the power factor. Then you plus x1, 2, 3 together. Then you get the power factor. Then continue as usual. Is it okay? You mean this question, right? Other question okay, right? This one, the three phase. This one, as usual. Nicholas done? One C. Maybe we use RMS, right? Yeah, you use RMS value. Mm. Positive. Yeah, positive lagging, negative leading, yes. Okay. Okay. Any other question? If no question, then for those who want to what fill for 1B? Screenshot. No need, don't screenshot it. I just tell this one is also not really correct. Okay, I just tell you how to do it, then you just do it yourself. Okay, the step is there. Okay, the step is there. You consider every load one, you get the P. Load one, you get the P, right? Then load two, you get the P as well. Then you need divided by 0.92. Then load three, from this voltage and current, then you can get the P. P equals IV, then divided by the 0.95, then you get the P value. So with all the P, then all the P, and with only this one, you have P and Q, right? Then you combine, plus all of them. So you have S1, S2, and S3, plus them together. So at best, S1 is basically 100 kilowatt lah. Okay. So this one also S, load 3, S, and P is the same. Then you plus them together, then you get the S value. After you get the S value, then what you do? Then you have a power factor. Then you improve that power factor to 0.95. Do as usual only. Okay. So no need to screenshot. I don't really like to show you my answer. Okay. You all should do and then show me your answer instead. This question? Why you like to do all my question? No, the steps is more important, okay? The step is not more important, okay? Exact value is not really important. Okay? Yeah, actually, most of the questions easy. Seriously, I don't have a lot of way to change the pattern of the questions. So it's hard to make it harder. Okay. Yeah, okay, please do more questions. I can only see Edin and Nicholas and maybe Renjian ask questions. The rest are very quiet. So I'm not sure if you are doing or not. Especially if you say your cost per is low, that means you need to work harder, okay? I hope nobody fail it, yeah? Okay, because it's an easy subject. And yeah, if you don't anything, then we will meet in the physical class next week. And let me know if you can't attend. So for those who would like to, yeah, discuss about your tomorrow your EM test or good luck. So why you have test I thought you test already that day. So if you want to ask about your test mark or what review your coursework, then you can stay. Do tests the lecturer so hardworking. I should give more tests also. Yeah, Edin buka puasa soon Okay. So if you want to review your tests or what coursework, then you stay and we discuss. Or no assignment. Okay. Okay, you can leave if you don't have any question. Bye.